Section 6.3 talks about trigonometric functions of angles. So let's consider a point in the rectangular coordinates. Pick an x, y. Assume it's in quadrant 1 just for simplicity, nothing more. If I am to create a triangle, that is, if I am to look at this and say, look, the x is actually this distance, and the y is actually this distance. And if I go on a straight path, if I call this r, this is my x, this is my y, well, I know a few things. If we're talking about the angle theta that it makes with that point when you line it up, then the cosine of theta would be, for that angle, the adjacent over the hypotenuse. The sine of theta would be the opposite over the hypotenuse. Of course, I could derive that. R the cosine of theta equal x, and r the sine of theta equals a y. And if I take tan of theta, that would be the opposite over the adjacent. Now, if I take the secant of theta, and if you remember, the secant was the hypotenuse over the adjacent, I notice that's the reciprocal of this. I notice that's 1 over x over r, which is 1 over the cosine of theta. Similarly, the cosecant of theta is the hypotenuse over the opposite. And that's really 1 over the fraction, and that's 1 over the sine of theta. And the cotangent is actually the adjacent over the opposite, and that, over the opposite, and that turns out to be 1 over the reciprocal of that fraction, which is 1 over the tangent. Those are the reciprocal identities. I do want to point out this is also y over r, and this is x over r. Do you remember you could multiply by the reciprocal and cancel them out? And isn't sine y over r and cosine x over r? So I have another identity for tangent. It's not only y over x, it's also sine over cosine, and that means that cotangent is the cosine of theta over sine of theta. Now I do want to point another thing out. I'm going to shift this to the left a bit. I'm deriving a few things for us. We're going to rederive those one more time when we get to chapter 5. And we're going to use them heavily there, but I want to derive them anyways. It's good to see it a few different ways. If I take the sine squared of theta, and I add it to the cosine squared of theta. Sine squared of theta, according to this triangle, this is the opposite, this is the adjacent, this is the hypotenuse. So hypotenuse is the radius, or the distance from the origin to the point. It's always positive. Sine is the opposite over the hypotenuse squared. Cosine is the adjacent over the hypotenuse squared. Wouldn't you say that's y squared over r squared plus x squared over r squared? Wouldn't you say all over r squared, that's x squared plus y squared? But who could tell me, given a right triangle, what does the hypotenuse equal? Isn't the hypotenuse squared x squared plus y squared? So can't I take this and say, wait a minute, but that's r squared over r squared, which is 1. So what did I conclude? I just concluded that the sine squared of an angle plus cosine squared of the same angle is always a 1. Now, if I divide this first equation by sine squared over sine squared is 1. Cosine over sine, we agreed that was the cotan. And 1 over sine, we agreed that is the cosecant. And if I go back to that same equation, the first equation, if I divide everything by cosine squared, sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. The reason I'm putting this on the side, we're not going to use it heavily in this section, but we're going to use it heavily in chapter 5. I'm going to derive it again when we get there using trigonometry, not geometry. Now, something that comes up when I talk about quadrants, I am associating sine of theta with y over r, and I'm associating cosine of theta with x over r, and tan of theta is the y over the x, or simply the sine over cosine. Now, if my point xy happen to be in quadrant 1, x is positive, y is positive. Now remember, r resemble a distance, so r is always positive. Always. Right? In this case, if you're talking about a triangle, it has to be strictly bigger than 0. Well, that means if y is positive, sine is positive. If y is negative, sine is negative. In quadrant 1, since the x is positive and the y is positive, so sine is positive, cosine is positive, and tangent, the ratio of this is positive as well. In quadrant 2, I know x is negative and y is positive. X is the cosine, so this is negative. And cosine, sine is positive. And if I take tangent, which is the ratio, positive divided by a negative is a negative. If I go to quadrant 3, I'll notice that both x and y are negative. So sine is negative, cosine is negative, but the ratio of two negatives will be a positive, which means tangent is always positive. And in this quadrant, cosine. So what we do, we memorize this by running in a positive rotation, and we read all students take calculus, which indicates in the first quadrant all trig functions are positive. In the second quadrant, only the sine is positive, which means cosine is negative and tan is negative. In quadrant 3, only tangent is positive, which means sine and cosine are both negative. And in quadrant 4, only cosine is positive, which indicate the other two functions are negative. Using this, along with what we're going to find as a reference angle, we're going to be able to do wonders. That's roughly a third of the class. What's a reference angle? Let theta denote an angle in standard position, meaning you start on the positive x-axis. That's what that means. The acute. What's acute angle mean? That means it's between 0 and 90 degrees. It could be 0, but it can be 90. Acute means something like between 0 and 90 degrees. Actually, if I really want to tie it down, I would always think of quadrant 1, where everything's positive. So the acute angle formed by the terminal side and the x-axis, always the x-axis, we never ever go to the y, is called the reference angle of theta. What that does, that carries the same characteristics as theta. So the choices are, or the chances are, I could be in one of four quadrants, either quadrant 1, or quadrant 2, or quadrant 3, or quadrant 4. So if I sketch an angle theta, I go from the terminal side, and what I do, I run straight down to the x-axis, always the x-axis. This is the terminal side and this is the initial side. I'd say that's the reference angle. If we're talking about quadrant 2, if you tell me the angle theta is right there, you could be in quadrant 3, or you could be in quadrant 4. If you are in quadrant 2, what I do, I go to the terminal side, which is the blue, and I run straight to the x-axis. The angle between the terminal side and the x-axis, that is the reference angle of theta. If I am in quadrant 3, I run to the x-axis, always to the x-axis. That right there is the reference angle. And if I am in quadrant 4, I would run from the terminal side to the x-axis, and this angle here would be my reference angle. What do we use reference angle for? Well, glad you asked, because I'm gonna elaborate on that. So let's find it, and I have some examples for you. I'm cutting this section in two, not because it's not doable, because I want to do 50,000 examples, and I want to make sure that you see it all. So 2 pi over 3. If we're dealing with radians, remember how this works. This is pi. In radians, pi is the equivalent of 3 pi over 3. So isn't 2 pi over 3 right there? If I want to find the reference angle is this angle. Always you run to the x-axis, you create your triangle. What would that be? So if I am at 2 pi over 3 and I want to know from 2 pi over 3 to 3 pi over 3, isn't the reference angle pi over 3? You could do what I just did, fill that in the actual triangle, or you could write it. Directions, find the reference angle I just did. There. And there. Oops. I messed up on that one. I meant there. That would separate all of those. And separate all of those. Here we go. So, what if I'm looking at this angle? 9 pi over 7. Well, do remember how this plays. 9 pi over 7. The angle itself, this is pi over 7. Isn't that 7 pi over 7? So isn't 9 pi over 7 a bit past that? We can say this is 9 pi over 7. So what are you looking for? You're looking for this angle, always the x-axis. If this is 9 pi over 7 and this is 7 pi over 7, can you tell me what that is? How about part D? Negative 2 pi over 5. Alright, I'm running in negative rotation. Okay, I get the idea. This is negative pi, which is negative 5 pi over 5. Isn't negative 2 pi over 5 in that quadrant? Because this is negative 2.5 pi over 5. So what's my reference angle? Students say negative 2 pi over 5. You got to be careful. It's an acute angle. It's between 0 and 90 degrees. So if this is negative 2 pi over 5, Wouldn't the acute of that be 2 pi over 5? And what if they try to trick us? Do you know what 3.2 is? Isn't this pi? Isn't pi 3.14? Isn't that a number? So 3.2 radians, isn't that a bit past pi? Just a bit. So how do you think we find that angle? We take 3.2 minus 3.14. Or we say it is 3.2. We never use 3.14. We use pi instead. That would be the reference angle. Degrees, it's really a lot quicker with degrees. If I run to degrees and say, all right, 70 degrees, well, I know where 70 degrees is. It's like right there. If this is 70 degrees, well, isn't the reference angle 70 degrees? It's the same if you're in quadrant 1. What if I'm running to 130 degrees? Like right there. If you tell me an angle is 130 degrees, wouldn't I run straight down to the x-axis and that's the reference angle? What is that angle right there? Well, isn't this 180? From 130 to 180, wouldn't that be 50 degrees? How about if I have 250 degrees? Well, 250 degrees, I know how that runs. That runs 90, 180, 200, oops, that's 270. So you can't. 180, 240 is somewhere in there. Right? Do remember this is 270 degrees. So if this is 250 degrees, the reference angle is really this angle, always the x. This is 180. If I am at 250 and I started at 180, wouldn't that make this 70 degrees more? So there are two angles you got to worry about, coterminal and reference, and they're both extremely important. Don't mix those. And just so that this doesn't look very confusing, let me cut it all out. This way we're dealing with literally different blocks. There. How about 305 degrees? Well, I get the idea. 305 degrees, I know how to do that. This is 270 degrees. So 305 degrees must be in quadrant 4. 305 degrees. But I know if I run all the way, this is 360 degrees. So what does that make this angle? From 305 to 360, wouldn't that be 55 degrees? And how about this problem? 5 pi over 7. Fractions are not going to leave you alone. This is pi. To make it over 7, to make sense out of this, that says this is a bit short of 180. If this is 5 pi over 7, and I'm looking at what do you add to that to make it to 7 pi over 7, wouldn't you say 2 pi over 7? So I'm trying to get you to get to those answers using common sense, assuming my common sense and your common sense are the same. How about 2.1? Well, again, always remember the trick. Pi is roughly 3.14. So 2 radians are about 144 degrees. They're really right there. This is 2. What would this be? If I told you this is 3.14 and this is 2, wouldn't you say this is 1.4? 1.14? How do you get that? You take pi minus 2.1, and that's the answer we want. We don't want you to use pi as 3.14. We want you to actually write it in terms of pi. What if the angle happens to fall on the x-axis? Well, to the x-axis, wouldn't that be 0? And how about 18 pi over 11? Well, this is pi, this is 2 pi. The only reason I only care about the x-axis because we always go to the x-axis. Never the y, always the x. So if I make him over 11, isn't that 11 over 11? And over 11, isn't that 22 pi over 11? Where do you think 18 is? Well, I'm confident 18 is somewhere in this quadrant. 18 pi over 11 is right there. So what am I looking for? Continue always to the x. If I am at 18 pi over 11 and I want to get to 22 pi over 11, doesn't that make this 4 pi over 11? Now what? Now we're going to make use of what you already learned last class meeting. And what is that? We have two triangles. We have a 30, 60, 90, 1, 2, radical 3. And we have a 45, 45, 90. And we know 30 degrees is pi over 6. And 60 degrees is pi over 3. So, if it's in degrees, no harm done. 210 degrees. If I asked you for 210 degrees, yeah, I overdo this. Extremely important. Again, this is roughly a third of what you need out of this class. 210 degrees, I really don't need to figure out a lot. I just need to figure out the reference angle. Why is that? 210 degrees is in this quadrant. There's the triangle. 210 degrees has a reference angle of 30 degrees. It's right there. What's the sine of 30 degrees? The opposite over the hypotenuse. Half of the problem is done. Second question is it positive or negative? All students take calculus. In this quadrant, tangent is positive, which means sine and cosine are negative. I could draw the triangle. The triangle would read, in that case, 30 degrees. This will be 1, but it will be negative because y is negative in that quadrant. This will be 2, and this will be radical 3, but negative. You could do that too if you wish, but those two triangles will save the day. 300 degrees. What's the reference angle to 300 degrees? 300 degrees to the x-axis. Isn't that 60 degrees? So 60 degrees reference angle. 60 degrees is right there. Cosine is the adjacent over the hypotenuse. In this quadrant, cosine is positive. Got it. So half credit will be given for you getting the value right, and the other half will be given whether you get me the plus or minus right. This is a third of this class. Negative 210 degrees. I don't care whether the angle is positive or negative. All what I care about is what's the reference angle and which quadrant is it in. Negative 210 degrees is in quadrant 2. And in quadrant 2, I know that only sine is positive, which means tangent is negative. It has nothing to do with the angle. It has to do with the quadrant the angle gets you in. If this is negative 210 degrees, this is negative 180. Isn't that 30 degrees? Here's my triangle. 30 degrees. I got all the values that I need. For 30 degrees, tangent is the opposite over the adjacent. You could rationalize, you could leave it like that, I don't mind. How about 135 degrees? Where would 135 degrees be? That would be in quadrant 2. In quadrant 2, sine is positive. Very good. What's the reference angle? The reference angle is 45 degrees. That triangle, what's sine? Opposite over. The back of the book will rationalize for sure. If you don't rationalize on the exam, if it's trig, I'll let you get away with it, because I'm a nice guy and all. Okay, well, watch the beauty of radians. The beauty of radians is, if you're dealing with the over 6, over 4, and over 3, guess what? Oh. The reference angle for pi over 4 is pi over 4, so you know it's 45 degrees. You know automatically it's this triangle. It's the hypotenuse over the adjacent. The question is, which quadrant are you in? Either you plot it, or you add 2 pi to it. Whatever makes you happy. Negative 5 pi over 4 is actually right there. And we know in this quadrant, sine and cosecant are positive, which means cosine and secant are negative. How about 5 pi over 3? If I make everything over 3, this is 3 pi over 3. This is 6 pi over 3. Isn't it right there somewhere? The reference angle, if it's radians, again, only if it's 3, 4, and 6, which is the majority of our class. That's 60 degrees. We already know that. 60 degrees is right there. Tangent is opposite over, you don't have to put over 1, but I'm doing that for your notes. And I'm in this quadrant. In this quadrant, only cosine is positive, which means tangent is negative. How do you like that trick? How about 11 pi over 6? Pi over 6. Pi over 6 is 30 degrees. 30 degrees is right there. Cotangent is the adjacent over the opposite. It's radical 3 over 1. You don't need to put the 1. I'm putting that in just for your notes. You have no idea how efficient this is going to be for us. That's how we're going to use trig. A combination of trig and geometry. Now, where's 11 pi over 6? Again, I know this is pi, which is 6 pi over 6. I know this is 2 pi, which is 12 pi over 6. Isn't 11 pi over 6 in there? Isn't in there. Only cosine is positive, which means this is negative. There it is. 3 pi over 2. 3 pi over 2 is a bit tricky. Just a bit. Actually, okay. 3 pi over 2 is at negative 3 pi over 2. It's along the y-axis. If you're along the x or the y-axis, for now, imagine you're looking at a unit circle. I forgot to mention that. I didn't know that was going to come here. I was going to do that next class meeting. Assume r is 1. So if you're dealing with a unit circle, and that's why I left this space, but let me do it now. If you look at a unit, it doesn't have to be a unit circle, but it works that way. If you're dealing with a unit circle, isn't that the point 1, 0? This is the, by the way, if you don't know what a unit circle is, it's a circle with a radius of 1. This point is 0, 1, and this point is 0, negative 1. And remember, sine is the y, cosine is the x, and tangent is the y over the x. So if I was to imagine this a unit circle, I'm right here. Isn't this point 0, 1? Which is the sign, the x or the y? Well, it's the y. That's a 1. And if I run to 5 pi over 2, if I draw a circle again, this is a special case. 5 pi over 2, that's like 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, you're right there. And isn't this sine over cosine? Isn't that 1 over 0? That would be undefined. How about this problem? Negative 300 degrees. Alright, negative 300 degrees has a reference angle of what? 60 degrees? In quadrant 1, they're all positive. And 60 degrees, cosecant is the hypotenuse over the opposite. Where's 60 degrees? Right there. Hypotenuse over opposite. 2 over radical 3. The book will rationalize that and say that's 2 radical 3 over 3. How about negative pi over 6? The reference in radians is very easy to find. It's pi over 6. It's 30 degrees. At 30 degrees, I know what the sine is. The sine of 30 degrees is the opposite over the hypotenuse. Is it positive or negative? Where is negative pi over 6? Right there. In this quadrant, we know that only cosine is positive, which means the sine is negative. Notice this was a negative angle, but the answer was positive. So the angle, whether it's positive or negative, it's irrelevant. It's which quadrant do you end up being in. This right here has a reference angle of pi over 4. I know the pi over 4, that's 45 degrees. The hypotenuse over secant. The hypotenuse over the adjacent. The hypotenuse over the adjacent. Radical 2 over 1. Or simply radical 2. Where is negative 3 pi over 4? In this quadrant, do you notice that tangent is positive, which means the other two are negative? So we're going to stop here, and we'll conclude this in our next class meetings lecture.